Hello guys, let's prove that on the second quadrant, sine is positive and cosine is negative without any geometry and without showing any graph. Now let's go ahead with the proof. So before we begin the proof, I'll have to assume one axiom that is always true. And I'm going to assume all trigonometric functions are positive for angles between 0 to 90 degrees and all trigonometric functions, meaning the 6 trigonometric functions. Now let's begin. So in the second quadrant, I know I said I'm not going to draw any graphs, but this is not part of the proof, this is just an explanation. So in the second quadrant, as you can see, this is the first and this is the second quadrant. And we want to know what angles lie between or lie on the second quadrant. So in the first quadrant, if we start from this line, we can see for the first quadrant it goes from 0 to 90. Now for the second quadrant, it goes from 90 to, well, I can't bend it all the way, 90 to 180. So we are dealing with angles between 90 to 180, and I'm going to let such angle, let alpha, and I'm going to let alpha be between 90 degrees and 180 degrees. And now what I'm going to do is I'm also going to let alpha be equal to 90 degrees plus some angle theta. And what do we know about theta? Well, from here what we can do is, first we can see that theta is just 90 degrees minus, alpha minus 90 degrees. Now if you subtract 90 degrees from all of these inequalities or from all of these sides, you'll see we'll get 0 on the left and alpha minus 90 in the middle, which is our theta, and 180 minus 90 is 90. So our theta lies between 0 and 90, which is precisely this. And I think I should also include this as well. Oh, oops, not here, right over here. Now we want to find both of these. Now let's start with sine. So we have sine of alpha. That is what we're trying to find, if it's positive on the second quadrant or not. We can write sine alpha as sine 90 plus theta. Now what can we do in the next step? Well, can we write it as is equals to cos theta? Well, no, because that would be circular reasoning. We can only write sine 90 plus theta as cos theta because we know it is positive on the second quadrant, and that is it. Otherwise, if it was in the third quadrant, you'll have to write negative sine theta, assuming it was 180 plus theta or something like that. But as you can see, we have sine something plus something, which is our sine a plus b. So I'm going to write it, the formula right here. Sine a plus b is equals to sine a cos b. Oh, this should be plus cos a sine b. So our sine a, or just a, is our 90 degrees, and cos just b is theta, plus cos 90 sine theta. Now we know what sine 90 is. It's just 1. So this multiplied by that is cos theta. Now what about this? Well, we know this is 0, and that means this whole term is 0, meaning we left with cos theta. Now how can we know this is positive? Well, I already mentioned theta lies between 0 and 90, and since all trigonometric functions are positive, that includes cos. So that means cos theta must be positive. And since this is equals to that, that must also mean sine theta is positive on the second quadrant. Now we can do a similar thing for cosine. So cos alpha equals to cos 90 plus theta is equals to, here you can apply the formula for cos a plus b, which is cos a cos b minus sine a sine b. And similar thing with this, which will be cos 90 cos theta minus sine 90 sine theta. Now cos 90 we know is 0, this whole term is 0, minus Sine 90 is 1 multiplied by that is minus sine theta. Now I don't think I need to explain again why this part is whole negative, because sine theta is always positive from this axiom, and since negative into positive is negative, that means cos alpha is also negative for the second quadrant. Now since sine alpha is also positive, that means it's reciprocal, which is cosine alpha, that will also be positive. And similar thing for cosine, sec alpha or on the second quadrant, or just the sec function on the second quadrant, will be negative. Now I will be doing the tan and the cot on the second quadrant, whether it is positive or negative, in the future video, because I want you guys to try it out first using this similar approach and see what you guys end up with, because that is a little tricky and you have to just do something a little bit different. So if you guys learned something new, please like and subscribe. Thank you.